And now we're going to know all of the angles are congruent between each other. Very quickly I can draw this because I put them in this specific order. Tick, 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 tick. And then we go and we put down information that they gave me. They gave me M is 112. I have B, I guess I didn't write this big enough, is 41 degrees. I have A is 13x minus 18. What else do they give me? They give me P is 2y. 2y plus 5. That's enough information. Because I now know that M and A are congruent, so these mean the exact same thing. If this is 112, then A is also 112. So our first equation should have been 13x minus 18 equals that 112. We should also had for that P and B are equal to each other. That should have been 2y. Oh, my thing came unscrewed. There we go. I would have that 2y plus 5 is going to equal that 41 degrees. And those are my two equations. Now I just got to be careful solving them. The first one, I'm going to add 18 to both sides. That's going to give me 13x equals plus 18 equals 130. Well, that's nice because that just gives me x equals 10. The correct answer for the first one should have been A, 10. Yeah?
Can you explain the 112 part?
What about it, I guess?
Like, never mind, I understand.
So they gave me that, so I just put the arrow as 112. And I just make sure you have your marks correctly. So I have 13x minus 18. These occupy the same space. This 112 could go to both of them. Okay, so that equals 112. Same thing here, that this 441, I could actually put that in both places now that I know that they're congruent. So this 41 actually goes there as well. So I'll have that 2y plus 5 equals the 41. Let's go ahead and subtract 5 from both sides. That's going to be 2y equals 36. And that gives me y equals 18. Look at the board. That is C. So we should have did A and then C. Questions? Let's all look up here because I know for a fact on the test I will ask you to put markings on this. You will lose points if you don't. Even if you get it correct, if I don't see the markings. Remember, read the directions. If it doesn't say you have to mark it, you don't have to. But if it says draw a picture and mark it, these are the markings I'm talking about. Yeah?
Would you count out for marks, like if you don't do it on proof?
I will not.
Okay.
But they are a nice cushion. If you get it wrong, I can see you did the marks and you forgot. So you'll notice on the quiz, like some people on proofs, like they marked that the reflexive was congruent, but they never mentioned it. I gave you more points, so I'll just put a little arrow going, you saw it, so I'll take off half point. Or if you don't mention it and don't mark it, then you lose a full point. All right, other questions? Crazy cool. What questions do we have from the homework? Go. 15. Yeah. So 15, we have a proof. Here's the good thing about the proof: we have a right triangle, which brings to mind that maybe it's HL. Maybe it's hypotenuse leg, because I said if it's a right triangle, perhaps we can use HL as part of the theorem. So we're trying to prove that these two triangles are congruent. So first and foremost, we have our given. I'm going to cheat and just put we have our given. Along with our given gives us a right angle, and it says that AB and DC are congruent. Now, Julian, I'm going to ask you a question. When I make these marks, are these directly across from the 90 degrees? If I draw straight across, would these be the sides across? Yes, which would make them the hypotenuse. So both of these are, in fact, a hypotenuse. That's probably a good sign for the hypotenuse leg theorem. So we have our hypotenuse, we have our hypotenuse. All right, so they gave me a right triangle, they gave me the hypotenuse. I need to find a leg. Julian, do you see anything peculiar about BC and BC between these two triangles? They're sharing it. So I'm going to use that reflexive property to say that these two things are congruent. So, and maybe I did my givens in 2 steps. Maybe my third step would be that reflexive, and that would be BC. Did I say BC? Yeah. BC is congruent to BC. That is our reflexive. And then my fourth step is I have a hypotenuse, I have a leg, I have a right triangle. So my fourth step should be saying they're congruent by that HL theorem. And they actually wrote the entire statement for us, so we just have to go ABC is congruent to triangle DCB. Good with that? Sure. All right, so what happens in my brain is right triangle means I'm going to start looking, do I learn the hypotenuse? If not, I have to fall back to side, 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 angle, side, angle. But if all of a sudden I have that hypotenuse, I'm probably using that HL theorem. Yeah?
Can you do 13?
13? I could take a picture of 13 because it's very much the exact same kind of proof. So 13. I see I have right triangles. That was given to me. So my given is that we have right triangles. And they also gave me the hypotenuse, just like Julian's question, because they give me WV. So I have WV. I'm sorry. No, I have WV and I have YZ. So they give me those are two congruent. And they also tell me X is the midpoint of YWY. Now, when I see the word midpoint, you better think of two congruent segments. Remember, you have this in your sheet. The definition of midpoint is it creates two congruent segments. So I go ahead and make my tick marks on WV and YZ. Make those tick marks. I write down the fact that X is the midpoint. Well, if X is the midpoint of WY, let's highlight that line. That's why I was able to put those double tick marks on there. Because of that definition of midpoint. And then you're done. That's just HL. I have the hypotenuse, and I have a leg of a right triangle. But the big thing there is understand what midpoint means. Midpoint means two congruent segments. Just like if I did an angle bisector means two congruent angles. All right, anything else? Okay, then the first thing we're talking about isn't really new. It's just kind of new how we're going to tackle it. These are called overlapping triangles, where I have triangles that are sharing kind of a lot of the same space. So one of the biggest things about an overlapping triangle, so we've already had ones that share a side. We use reflexive to say, okay, they're right next to each other, they share this side. Now we're going to talk about triangles that might share a side, they might actually share an entire angle. So if we look at this first one, it says, what common angle do ACB and ECB have? Now, we have kind of two ways to tackle this. The first way is we could take colored pencils and color in the two angles that we're talking about. So I'm talking about that one, and I'm talking about ECB, which would be this triangle here. So they're specifically talking about those two triangles. What I do with pencils, I just shade in one of them. But one of the more common ways to deal with this is to actually just redraw the triangles, but separated. So I'm going to draw that pink triangle first. That pink triangle was ACD. And then I'm going to draw the other triangle. I just split them apart. Doesn't have to be perfect or pretty. Just make sure you get the letters down correctly. Now, when I say they share something, they have to share 100% of it. So if I look at this segment CD, so this triangle has the entire CD on it. Does the other triangle have a side CD? No. So in other words, if I found out that CD was 6, this would be 6, but would this entire length be 6? No, so that's not shared. That's not what we're talking about with share. They have to share the entire thing. So these don't actually share any sides. However, do you see this angle C right here?
Yeah.
Do they both have the exact same angle C? In other words, if I put like 75 degrees here, could I put 75 degrees here?
Yes.
Could I put 75 degrees here?
Yes.
Yes. This is our reflexive property, but with angles, that they would share C between them. Now, here's a mistake that people make. See this little pink angle right here? Does that little pink angle exist on this triangle over here? No, they don't share that. They have to share 100% of it. 100% of the angle must be shared. That's what we talk about with shared. So the only thing they have in common is angle C, and that would be through the reflexive property. That would also be our reflexive property. Make sure I didn't miss anything along the road. So these have a common angle, and that would be through the reflexive property. So if I was doing a proof, I would say, oh, by reflexive property, C is equal to C. Our next one, there's a bunch of triangles there, aren't there? I could see like this triangle here, I could see this triangle here, I could see this triangle here, I could see. So you really have to pay attention to the directions. The directions say A, B, D. So let's color in A, B, D. I'll do that in green. A to B to D. To make a triangle, we go all the way across here. Our other triangle, it says, look at DCA. DCA is this triangle here. Do you guys have the C one? Do you have a C on your sheet? Do you have this one, I mean? You have that one? Let's just cross it out. We don't have enough room. We're just going to cross that one out. Okay, I just want to give myself enough room for this one. So if I look at my two triangles that I just drew there, I have this triangle here. I'll make it green. That was my A, B, D triangle. And then with my pink one, I have this triangle here. Let's call that, this is our CDA one. Do those two triangles share anything? Remember, when I say share, they have to share 100% of it. Santiago?
Yeah, they both have a midpoint of BD.
They both have a midpoint of what?
BD.
Of BD. Well, we don't know that's a midpoint. It doesn't say it's a midpoint, does it? So I think you're saying like they both would, I could put a point in both of these and it'd be a midpoint? Is that what you're kind of saying? Yeah, they don't share that because we don't know it's a midpoint. We don't know for a fact it's a midpoint. When I ask for shared, I'm looking for entire length or entire angle. Yeah, Joseph.
AD.
They have a shared side AD. They have this side right here in common. And I think the easy way to see that is when we strip them apart. Because some people will say they share angle D. Do both of these angle Ds look the same to you?
No.
No, they don't share the entire thing. If I look at A, they don't share the same A. If I look at B, they definitely don't share B. The only thing they have is the same side. So in this case, they just have a shared side. They just have a shared side. And once again, if I was doing a proof, this would be the reflexive property. So it's going to be important for us to understand that they have shared stuff. This one has a common side. This one has a common angle. Because we're going to have to go back to overlapping triangles that I have to write congruency statements about. That I need to be able to write congruency statements about. So if I look at the very first one, I see two angles, but that's all I see. You know 3 parts to show things are congruent. If I have 2 angles, it has to be angle, angle, side, or angle, side, angle. So it is our job to understand that I have to find the missing part. So if we look at this first one, and I highlight some triangles. Now, I'm going to highlight the triangles that they have marked with angles. So I'm looking at this triangle here. I noticed they marked both of those angles on that triangle, so that must be one of the big ones I'm talking about. Then the other triangle they're talking about must be this one here. Let's go ahead and use green to mark the other one. Now we have a bunch of congruent angles. Do either of those triangles share a part with the other triangle? We should all be looking at it, not at our pencils. We should be looking up here or in your notes. Do they share a side or an angle? Same, 3 people raising their hand. Awesome. Yeah, Savar.
They share NP.
They share the side NP. If you color this in, you'd realize you colored the exact same thing in twice. They share this side here. If I was to split these two triangles apart, I'll try to split them apart in the exact same color they're in. We would have that one. We would have the green one. The terrible green one. I'd put the same marks that are on there. So if you look at the pink one, I have a 1 mark up here. I have a double one down at this angle here. Maybe I can actually put my letters down. Not be lazy, not be lazy. Put my double one there, and I could put my tick mark here. For my green one, I have NPO. I put my tick mark here, double tick mark, single tick mark. Mark all congruent angles inside, and I'm supposed to write a congruent statement. First of all, can we write a congruent statement?
Yeah.
Are these like side, 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 angle, side, angle, side, angle, 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 side? What would these be? Yeah.
Angle, angle, side.
These would be angle, angle, side because I have 2 angles in the non-included side. So this would be angle, angle, side. And my congruency statement could be triangle, I'll just go MPN is congruent. So look at MPN, that's 1, 2, and then none. So 1, 2, none should be ONP. Did I get that correct? Is MPN congruent to ONP? Good with that? Any questions? Okay, if there's no questions for me, I'm going to give you a hint on the next one. And you and your partner are finishing the last 2. You and your partner are finishing the last 2. Make all of your marks. Split the triangles apart. See if they share any common angles or sides. If you have questions, ask. I'm going to go ahead and we're going to skip C just so you have a little bit more room. I realize that we didn't quite have enough. A, B, C, that'd be congruent to triangle D, B, E. Okay? All right, so your big thing about with triangles is split them apart. All right, that brings us to proofs. We can be doing proofs just like we've doing any other one. The only difference is the reflexive thing might be hidden. Our Our reflexive thing can be hidden. So if I look at this one, we'll start off with what's given. So I have W. Did you have a question? Okay. So if I had number 1, if I had WX is congruent to VT, I would go up here and I'd make my mark WX and VT. And in fact, I'd probably off to the side maybe draw both of these triangles just by themselves. I'm just going to get in the habit of splitting these apart. Actually, let me make my markings first, then I'll split them apart. Then I also have that angle TVW is congruent to angle XWV. So TVW, now you got to be very, very careful that you do this correctly. TVW VW is this big angle here. So it'd be that entire TVW, which would be this entire angle here. Make sure you go far enough. That is congruent to XWV. XWV is this entire big angle here. So then if I rewrote these, I got to write a little small. I kind of didn't give myself enough room on my drawing. But if I draw that first one, that's my TVW triangle. I can put a big arc at V on this one and a tick mark on VT. For my other triangle, I can put my tick on W, that whole one, and I can put, I have a V, I have an X, and I have a tick mark here. So I just spread it apart with my tick marks. So now I have side angle. They gave me side angle, and that was all covered by my given. Your job is to see if they share any parts that weren't notified by my given. Do these triangles have any reflexive parts? Parts that they share the entire thing, whether it's an angle or whether it's a side? Will?
Angle Y.
Angle Y? Probably not. That's in the middle and it's a whole bunch of different angles. What else do they share entirely, Julian?
VW.
They share the segment VW. So if I look at VW, if I draw this green one, it would cover that one. If I drew this one, it would cover that entire line as well. So VW, I could put a mark on VW on both of these. I can come down here and say number 2, VW is congruent to VW, and that is our reflexive property. And then I'm done. I now have side angle side. So my step 3 is triangle TVW. If I could get to VW, is congruent to triangle XWV. And that's just going to be side angle side. Overlapping triangles are as difficult or as easy as you make them. They just take practice. Understanding what I mean by overlapping and that reflexive property, and not just picking any angle you see out there. Make sure it is fully encompassed in both triangles. All right, our next thing we're going to do is, and this is really a big chunk of this lesson, is using CPCTC. We did CPCTC. It is in your theorem postulate sheets. You might want to take those out because this is going to be a key thing to be able to solve a problem like this. CPCTC, I'll wait till everyone gets it out and looks at it. So we're looking at the theorem postulate sheets from this unit. I think is it the first thing I wrote on there? CPCTC, and I talked about it before. That is, can someone read that to me? Yeah.
Corresponding parts of congruent angles are congruent.
Corresponding parts of congruent triangles are, oh, you're kidding me. You're going to pick that up at student life, okay? Because these need to go on there. Okay, so corresponding parts of congruent triangles are congruent. What that means to you is as soon as you show that two triangles are congruent, all of their parts are congruent. So what's happening here is, notice how I have given triangles, but I don't need to show they're congruent. I need to show that these parts are congruent. Your job is to understand that sometimes proofs don't end when you show that triangles are congruent. Sometimes you have to do one more step. So although it says I need to show that these two parts are congruent, I actually first have to show that the triangles are congruent. And I try to help us a little bit by drawing a diagram off to the side. So we already have stuff marked up for us. We just have to write down our given. So let's go ahead and mark down our given. We have ZXW is congruent to angle YWX. And we'll have angle ZWX is congruent to angle YXW. That is my given. That is my given, and it's written on there. I drew all of the stuff on there for you. So I made all my markings on there, and I split the triangle apart. I need to show that these two things are congruent, which means I need three things. I have two angles, and I'm missing a third part. Our job is to come up with these two triangles overlapping, do they share a part? Higher angle W, though?
No.
Because I already have, like, this is, from this one, it's a big angle, and for this one, it's a small one. They have to share 100% of it to say they share it. Yeah, Hogan.
Side WX.
They share side WX. If you look at both triangles, they're stacked on top of this WX. So even if we look at the picture, I have WX and WX, they must be the same length. So I can go ahead and make tick marks on WX. And I can go ahead and say my second step is WX is congruent to WX. And that is the reflexive. Step 3 is I have angle, side, angle. So I can say these two triangles are in fact congruent. So my step 3 can be triangle. Let's call it WXZ is congruent to XWY. Did I name those correctly? WXZ is congruent to XWY. Did I name those correctly? I did not. One person says no. One person says yes. I heard a no, though, so I should double check. So WXZ should be double tick mark to single kind of curve mark to nothing. XWY, double, single, nothing. It is correct. It is correct, and this would be by angle, side, angle. Now, because I said these are congruent, I could now say angle Y is congruent to angle Z. I could say WZ is congruent to YX. I could say WY is congruent to ZX. That's the point of showing that they are in fact congruent. So now that they are congruent, I can say any congruency statement I want. And that includes ZW is congruent to YX. So that is going to be my next step is I'm going to say I'm done. ZW is congruent to YX. And that is going to be CPCTC. Easily rememberable by Kapukatika. Said that before. Super easy to say. It rolls off the tongue. Kapukatika. CPCTC says if I have two congruent triangles, I can now say any parts are congruent between those triangles. As soon as I say triangles are congruent, all the parts are. So CPCTC is really one extra step from all the proofs we've been doing so far. So moving forward, if you see triangles and you don't see that I'm proving that the triangles are congruent, we're probably using CPCTC to say that those parts are congruent. So real quick, one more example of this. Yeah. All right, so another prime example of this is this one. We have a given. We have two givens. We have CA is congruent to CE. We have BA is congruent to DE. And that is given. All right. What was that? Does it say anything about a midpoint, though? It has to say midpoint for you to use anything about midpoints. It has to say that. All right, so let's make our marks on this one. So it says CA and CE. So CA and CE would be this whole line here, and CE would be this whole line here. BA and DE. BA would be right here, and DE would be right here. Okay, let's split apart the triangles. And I already have those written down. So this is a rather kind of tedious kind of proof, actually. It looked easy on the first one. This one's going to be a little more tricky. So let's just go ahead and make the marks that we can. So I know that AB is congruent to DE. I can mark those on that one. I also have CA and CE. Maybe we'll have to use that in a second. Joseph, what else could I put on this?
Congruent to AD.
Oh, I could put AE is congruent to AE. I could say that. Why can I say that? I can say that one more time. Reflexive property. So I might as well say that. So I could say step 2 might be, at least I can have AE is congruent to AE. That was something I could see. That is a reflexive property. What else is something I could put on here that I could just visually put on there? Can you help us out? Don't just copy our stuff. What else do you see up there that you could just see and you could write something down?
Side, side, side.
I can't say side, 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 because I don't think I said BE equals BDA yet, did I? To use side, 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 I'd have to go side, side, side.
Oh, I was thinking of like the bigger triangle.
The bigger triangle, well, I have one side, I got that side, I'm missing this side to do that.
CP and DA doesn't count as like two different sides.
That works, nope, because we're looking at that big triangle. So what I'm looking at right here is this big triangle here. And maybe it'd make more sense if I drew this. That this triangle here only has these 2 marks on it. That's it. Yeah, what else could I put on there maybe?
Maybe ABE is congruent to EDA.
ABE is congruent to which one?
EDA.
EDA, why?
Because I'm not sure.
Okay. If we're not sure, then we can't put it down just yet. There's 2 things that I can see on that drawing that we could add to just based upon the drawing. Yeah.
Can you add the AE congruent to the big triangle?
The which one?
The AE is congruent to AE.
Well, I could say it's congruent to itself, but that doesn't mean it's. So I could put that on there, but that doesn't really help me. I could put it on there, but it doesn't really help me anywhere because it doesn't show it's equal to anything else. I love all the people that aren't even looking at it. That are just like, I'll wait for someone else to say it. There's 2 big things that people are missing. 2 huge things that are up there. Yeah?
The tick marks on the 2 little triangles to the left.
We don't have any tick marks I could put on there. Oh, yeah, we can do that. I'm sorry. Yeah, we skipped that. So we should put these double ones on there. We did have those. That's a good point. Joseph, what do you see? Okay.
Isosceles triangle.
I see an isosceles triangle. What's important about an isosceles triangle?
The angles are congruent.
All the angles are not the same. That's an equilateral triangle. For an isosceles triangle,
The sides are to the side.
if both sides are congruent, what else do we know? The 2 angles are congruent. So because we have an isosceles triangle, our base angles must be congruent. So now I finally brought angles into the mix. So I can now say, step 3, angle A is congruent to angle E, and that's the isosceles triangle. It's either the theorem or the postulate that says, or converse. Is it the theorem or converse that says take the sides to the angles? It is the theorem. The converse goes from the angle to the sides. Okay, so let's mark all those. Let's mark all those A's. All right, we need to somehow get to BX is equal to DX, though. I need to show that these 2 triangles are congruent. What do we know about these 2 triangles? Side, angle, side. Those two triangles are congruent. Now follow my thought here. If these two triangles are congruent, what do I know about BE and DA? They're congruent. Okay, we're getting somewhere. We're getting somewhere. So maybe we just go ahead and say that these, because you see how BE and DA kind of form these triangles here? So maybe that's getting us somewhere. Maybe that's getting us somewhere.
I don't see how they form those triangles over there.
What was that?
I don't see how they form the triangles to the left.
Well, they actually form a couple different parts. It's actually going to be, I think as Alejandro pointed out, this B and D angles. Those are actually going to be important to us. Let's just go ahead and prove that these two things are congruent first. So let's say these two triangles are congruent. So my step 4. My step 4 is to say that triangle, I'm going to go ABE, is congruent to triangle EDA. And that's going to be by my side, angle, side. All right, now pay attention to this next part. That means anything from this triangle is congruent to anything from this triangle. So we could say that BE is congruent to DA, which would be cool, but is X a midpoint? Do we know for a fact X is a midpoint? No, so maybe that won't be useful. But Alejandro said something important. Yeah, Santiago.
Maybe you say vertical angles?
I could say vertical angles. Let's hold on to that. That should have been the first thing we said. The very first thing we should have said is vertical angles. But I'm going to hold off because no one said it, but we're going to bring it in a second. So we're going to be able to use vertical angles in a second. So let's hold on to that we can use vertical angles in a second. Those will be our vertical angles. What can I say about angle B and angle D right now? Why? CPCTC. So because of CPCTC, I can now say that angle B, and I'm going to do this in red with 3 big tick marks, 1, 2, 3, that these two things are congruent by CPCTC. Kapukatika. Kapukatika tells me that angle B is congruent to angle D on those two drawings. That is our CPCTC. And I can make those marks on here. And Santiago, noticed we had vertical angles there. So we could now say that, what is that, angle BXA is congruent to angle DXE. That is going to be vertical angle theorem. Step 7, Oliver, you got all these? Step 7, I now have angle, angle, side between these two triangles. So I can now say these little triangles are congruent. So we can go ahead and say triangle ABX is congruent to triangle EDX. And that's by angle, angle, side. And because those triangles are congruent, we can go all the way to say that BX is congruent to DX by CPCTC. I do not expect you guys to be able to do this proof on your own. So don't let that freak you out. But you should be able to pick out every element that I did, that we could have proofs that have important stuff like this. I'm particularly looking out for, understand that the isosceles triangle theorem and converse can show up in proofs. If you put a triangle that's isosceles, you better be able to say the angles are congruent. You should be able to pick out vertical angles. You have to start being able to pick out that if I'm missing sides, I'm going to use CPCTC to start finding sides. That means I need to show triangles are congruent first, and then I can use CPCTC. Yeah.
Someday are we gonna like do this ourselves?
No. I don't expect you guys to get to this. Some of you might. Some of you might have looked at all this and been like, yep, I understood all those steps. And some of you might have been like, oh, I would never be able to see that. It's fine. This is a pretty tough proof. This would be like a proof if you're in honors. This would be something if you're in honors they might do on like their test because it involves 2 CPCTCs and understanding how to link things together. We just don't have the time. If we had like several days we could focus on CPCTC, maybe I'd expect it out of you. But realistically, we have today. We'll do some practice proofs, and then we have to start preparing for our test. Questions? So I don't want to stress anyone out. I just wanted to expose you to a nice, difficult proof. Like, it was great if you understood the steps and you were thinking ahead with me. If you were just someone that just sat there and didn't do anything, I feel bad for you because you're not understanding like the importance of proofs and how to do these things. You should be at least thinking through with me. Don't just copy things down and go, I don't know how to do that. Learn. Stay with us, ask questions, and move along with us. All right. That being said, that's all I have for you today. I think we're almost done.